was asked to present the Eurofiling data modeling and the ExcelXbrl generator, the tool that we use in the Eurofiling to develop taxonomies according to the agreed architecture. I prepared a bunch of slides. I'll show some of them. Most of them are self-explanatory, so if there is something that I skip because of the lack of time, these slides will be available on the Eurofiling website. So the agenda for today is to discuss the data model, the purpose, challenges, and solutions of data modeling, especially in the supervisory environment. Then I'll try to present the information requirements related to specifically FINREP, COREP, and the statistics, and how these were reflected in our data models. The next point is a short explanation of how the taxonomy, the draft taxonomy architecture is designed, and how the data model translates in taxonomy. The next point is the introduction to the Excel tool, and the last point is show how this Excel tool works in practice so that you can try it yourself with the materials that are available on the Eurofiling website. So first, the data model. What is the role of the data model in financial reporting and exchange of information? Supervisors need to do their work, and their work is mainly to analyze and audit data sent by financial institutions and other non-financial companies in order to make sure that we don't have any more crises like we had a year ago, 2 years ago, and earlier. But in order to conduct this analysis and audit, they need data. So they have to write regulations, standards, guidelines, and other materials in order to communicate to reporting entities what data needs to be submitted and exchanged. Of course, this exchange means that there have to be some protocol that will communicate between the systems of filers and the system of the supervisor that will describe what the data should be exchanged and in what format. So the reporting entity must be prepared to submit the data requested by supervisors. The problem is that there is no clear linkage between the data requirements defined by business users, business experts, and the data exchange format, which in case of, for example, XBRL and XML, is typically built by the IT specialists. So what they need is a common middleman that they both understand and are able to develop the taxonomy based on the information requirements, and the connection is one-to-one. So there is no discrepancy between what is in the taxonomy and what is defined in the regulations. In the Eurofiling project, we deal with a number of international standards. The most important one are IFRS and the Basel II. And in this project, it's the European Banking Authority who is responsible to adjustment of these two standards to the European needs. There is another big player, which is the European Central Bank. For statistical reasons, it also gathers a number of important information from the filing entities. In order to make sure that these two organizations do not define different requirements and follow the same breakdowns, there is a joint experts group on reconciliation which identifies the same elements and the same breakdowns applicable by ABA and European Central Bank. Then there is the standard XBRL, which was selected by the Eurofiling for development of the taxonomies. This is the technical standard. So we are capable of developing the XBRL taxonomy. The thing is that what we need is a data model which is built in cooperation with EBA and ECB and other interested parties so that the information requirements are correctly reflected and designed in the taxonomy. In terms of the format of data exchange XBRL, the case is pretty simple. XBRL can describe in taxonomies and exchange an instance document the information requirements. Moreover, this is data-centric format, which means that the focus of the format is to consistently define reportable information. And in this term, we shall not focus on the views of the data, but rather the model that is behind the data. Each concept is reflected in XBRL taxonomy using XBRL syntax, but this syntax carries certain semantics. This semantics is in the data type, in the period type, in the applicable breakdowns, documentation labels, references, etc. So the semantics that we reflect with XBRL syntax must come from a data model, a consistent data model that is developed according to Eurofiling information requirements. So let's take a look at these information requirements. In general, what we deal with is international financial reporting standards and their application by the Europe, the Basel II Accord and its application in Europe by special directives of the European Parliament and the Council, the guidelines on common reporting for core FINREP developed by the European Banking Authority, which tries to standardize the IFRSs and the European regulations and develop some common templates and framework for reporting of core and FINREP. There are also requirements of European Central Bank concerning different statistics related to monetary policy. And the issue that we have is, apart from these different regulations, they also come in different format. We have textual standards, guidelines, and directive, tabular format of the guidelines of EBA or ECB, enumerated lists indicating the applicable breakdowns. So somehow we have to analyze it as a whole and be able to apply a consistent model. So the challenges is, first, we have different scope of data depending on different purposes of the data. We have financial reporting for the IFRS and FINREP, solvency reporting for the Basel II, statistical reporting for balance sheet information and interest rates, and so on. We also have different sectors, in fact, because we have Basel II versus Solvency II, so credit institutions and, in particular, insurance. The same with IFRS. IFRS 9 applicable to credit institutions and IFRS 4 applicable for insurance. There is different granularity of data in different countries. You can see that European countries extend or reduce the number of concepts defined by the core taxonomies in order to reflect the national flavors. There is also a requirement that the data is analyzed comprehensively. So we need to have experts in each of the domains in order to tell us exactly what was the purpose and what is the meaning of the particular section. But we also need people who have the general view and the higher level view on the entire discipline of the financial reporting, because they are able to identify similarities and they're able to help to harmonize the data across the different frameworks. And also what we need is resources who can anticipate the changes. For example, the way the FINREP was modeled 2 years ago already anticipates the changes resulting from the IFRS 9. So you can see that in FINREP core or statistics, we have a number of tables. Together approximately around 100. Some of them are pretty big, some are very, very little. But at the end, what we have to do is to try to analyze them and figure out if they have something in common and try to aggregate and segregate what they have in common. So if you take a look at the FINREP tables, you will immediately see that you start with the core tables, balance sheet and income statement, and the rest of the tables is just a disclosure, which are detailing. For example, it's, I believe, table 8, which details assets according to the geographical residence of the counterparty. Another table does the same, but they break down the different kind of instruments according to what is the counterparty sector that issues this instrument. Similarly, we have information that is aggregated in the balance sheet and disaggregated in the other tables, or vice versa. In this case, impairment on and past due information on assets takes into account only the instruments but ignores the portfolio. We also have similarities between the balance sheet tables. As you can see, assets and liabilities have a lot in common, especially the financial instruments section and the section that is applicable for tax and insurance and reinsurance contracts. This is identical in both cases. Also, there are tables that merge information from assets and liabilities side in order to indicate, for example, notional amount of derivatives. There are even more relations. Assets, of course, are related to equity in terms of revaluation reserves, which goes, on the other hand, to the comprehensive income statement. Similarly, the income statement and the assets and liabilities side have a lot in common, because what is in the income statement is the result of what was in the balance sheet. So if we sell an asset, or the assets is worth more with time, it goes into the income statement. There are also relations between other tables that are not really on the first look applicable for the balance sheet, but at the end you'll turn out that they are in fact subclasses of what goes into different components of the balance sheet. For example, collaterals obtained during the period are different class of assets, and depending on what they were, they end up in the balance sheet. I could name a number of different relations between tables. For example, here where we have table of movements, we have provisions in the balance sheet, and we have the same provisions which are analyzed according to the changes and the beginning and ending balance. And it's not only the tables that have the impact on what is reported, it's also the supporting documentation. For example, the guidelines in point 4 state that there are two types of consolidation scopes that can be applied for FINREP. The IFRS consolidation scope, which is the regular consolidations of all subsidiaries, or the CRD consolidation scope, which guides to exclude from the consolidation those entities that are not financial. Because if a bank has, for example, a shop, and this shop has receivables, it doesn't make sense that these receivables are measured according to the complicated methods used in the banking supervision. So the solution that we have is to divide and conquer. This is the name was brought here by a friend of us from the Bank of Spain, and it's very, very applicable. It comes from the information technology, but it's also applicable to data modeling. So if you have a problem, if you split it in many little problems, it's easier to solve it. So what we do is, looking at the black and white templates, we try to add them some colors. So we try to figure out those bits and pieces that have something in common. The views not necessarily give this impression at the beginning. You can see the balance sheet, you can say, well, these items have something in common because they are in the balance sheet. But in fact, there are some more consistent groups that you can classify it instead of balance sheet items. If we do it for each of the table, we will see that the numbers of these different bags is growing. And we also can go back to the table which we already analyzed and try to figure out if there is anything that we forgot, but it comes from another table. So in this case, in colors, I have different members of different breakdowns, and these breakdowns are consistent, which means that we don't mix apples with grapes. Every time we do a classification, we try to be consistent in terms of what goes in this particular bucket. So how does it go? How this process looks? First of all, we have to analyze the purpose of each table. This purpose is expressed in the title of a table. It says more or less what is the content of the particular table, what is the breakdown that is applicable, what is the purpose of it. Then we try to figure out the information from the intersection of header of a row and header of a column, because at the end this is what ends up as a data point. Of course, location in the hierarchy of headers of rows and columns is also important, because some information is sometimes lost. It's implicit because it's human beings to read it from the inheritance of the headers of rows and columns, but it's not explicitly stated if we look only on a single row. There is also things that is defined in the supportive documentation. This is also important to make sure that when we analyze FINREP, we have to have a good knowledge with IFRS 7, IS 39, and all these standards that are applicable for financial institutions. Guidelines themselves are not enough. And this model is recursive, so every time we add something to this model, in fact, what we do, we have to look also at the other tables and other components that we've already analyzed and figure out if the new thing is applicable also in other places. So the characteristics of these bags, these breakdowns that we try to define, is that they have to be coherent. So a set of items within a breakdown have to be in some kind connected. By doing so, we are able later, and I will show you that on slides, we are able to manage a change, because every time there is a change, we are clearly able to state in which place this change appeared, to which breakdown it's related. And it also minimizes the redundancy, because we have the bags which we can reuse in many cases. So the result is consistent and explicit data model. Here is an example of how we do it. I'm sure that some of you have already seen that, because it was presented during the Eurofiling workshop and the XBRL conferences. But imagine this is a balance sheet of the requirements for the ECB statistics. This is actually an asset part of the balance sheet. So the first property that we can find in here is that we are talking about assets. The rest of the information is hidden in the additional documentation, in the title of the table, and in the headers of rows and headers of columns. So let's analyze these headers of rows, columns, and the documentation. Let's start with headers of rows. The first classification that we can see here is that we have different categories of assets: cash, loans and credits, debt securities, equity instruments, fixed, and other than these. As you can see, under number 4 and 5 in the headers of rows, you have actually different titles. You have investments in money market funds, and you have equity instruments. But in fact, investments in money market funds, they are equity instruments. So that's why we classify them under the same category of assets. Normally, if you were defining this and you didn't know about the semantics that are behind it, you didn't know what is the purpose and the reason for this table, and you wouldn't have the business knowledge, you would probably create a new concept, which is investments in money market funds. The thing is that money market fund is just a counterparty that actually issues a special case of equity instruments. So this is the first thing when you can see that actually defining these bags is not an easy task, because it's not a simple classification. You have to have a domain knowledge. The next classification that we have here is different counterparties. So these are the counterparties that actually issue these different instruments. As you can see in this particular case, we can also see that the money market funds are a special category of a counterparty. You can also see that we have alternative classifications. The reason for that is that every time we define a bag, we put all the elements that have everything in common in this bag, but then we try to define a hierarchy. Because when the bag grows, it's sometimes difficult to figure out what is the relationship between these elements in the bag. So what we do, we define these hierarchies. The thing is that these hierarchies can have alternative classifications. In this case, the non-monetary market funds cannot be classified in the upper breakdown for counterparty sector, because they will break the hierarchy. I will show you that later on a different example, which is easier to understand. The next breakdown that we have here is the original maturity of financial instruments. As you can see, it's only explicitly stated for the debt securities. However, we already know that loans and in this case only loans and credits can also have original maturity, which means that in this particular table, the total is required. And then we analyze the headers of columns, and there are two breakdowns. One breakdown is the counterparty residence, where we have different geographical areas, and the other breakdown is the original currency of the instrument, which we have euro and other than euro. And the combination of these two informs us what is in the headers of columns. So if we pick any cell in this table after doing this analysis, we are able to say what it is. This particular cell that I picked, it informs us that this is assets, this is debt securities, because I can see it in the headers of rows. It's monetary financial institutions, again, from the headers of rows. The original maturity of this debt security was between 1 and 2 years. The counterparty residence, according to the header of a column, is Spain. and the currency, original currency of this debt security was euro. The thing is that there are two more pieces of information here which are not taken into account because they are not so explicit. First of all is location of activity, which is businesses in Spain, which means that this table is applicable only to this business of the reporting entity, which is done in Spain. Additionally, what is the measurement of this debt security? Is it fair value? Is it carrying amount after impairment, or something else? In case of statistics, it's the outstanding amount, so the amount that needs to be paid in the future. The other thing that you may find interesting is that we have two different dimensions or breakdowns referring to the same concept, in this case, Spain. So when we define these different bags, we classify them not according to the dimension, but according to the domain, which means the set of items that have something in common. We wouldn't define a new list of countries for counterparty residence and the separate list of countries for location of activity, because it doesn't make sense. We have a list of countries, which is a stable thing, and then we can view it from a different perspective. To show you that on example, here is one where we have a different table from the statistics. As you can see, this is information on certain loans. And we already have two breakdowns from our previous table that we can apply in here, which means that this is loans and credits as a category of assets, which we had also in the previous table. And in the counterparty sector, under the non-MFIs other than general government, we have to add two new members, which is non-financial corporations and households and non-profit institutions serving households. So two new members in one of the dimensions. But then, as you can see in this table, we have different time intervals. Under 1 year, over 1 year, etc. But they are the same thing. They are different time intervals, but applicable from different perspectives. The first one is we have original maturity over 1 year, which means that when this loan was issued, its original maturity was over 1 year. But since it's already some time after it was issued, the remaining maturity is under 1 year. And the other characteristic that we have here is the revision of interest rate. So when we expect to change the interest rate, if we plan to do that. Similarly with the geographical areas, here we have also two subdomains. And the reason for that is that we are not able to actually have or try to model other than Spain inside of the subdomain 2, because these breakdowns are mutually exclusive. Because in subdomain 2, Spain is under EMU, which is the European Monetary Union. We're not able to assign on any of the level other than Spain because we'll have it exclusive. So we need to define two subdomains. And then in this table we have three different dimensions that refer to our geographical areas. First dimension is businesses in Spain. The second one says who was the counterparty to whom we gave this loan. And the third dimension says because these loans are under securitization, what was the counterparty that was the middleman in this securitization? Where was this counterparty from? So as you can see, one domain and three different dimensions. So what do we do with these bags later? Of course, we can define the data model and we have a nice semantic view on what is the reported information. But is it usable in the future? Well, yes, it is. When we have these different breakdowns, we can later create a different hypercubes that actually link this data together. So we can say that loans are always broken down by different maturities, different counterparties, different sectors of the counterparties and their residences, etc., etc. So we can define big hypercubes from the consistent breakdowns. This helps us to define static views in the BI systems and refer back to the original templates of the data model, but also this allows for dynamic analysis, where we can create many queries based on the consistently defined data. For example, if we define an SQL query on this kind of data model-driven database, we select a sum of fact value from the all facts table, where item is assets, and portfolio is held for trading, and category derivatives, amount notional, counterparty residence UK, counterparty sector credit institutions, original currency euro, risk type commodity, market over the counter, etc., etc. all these properties were identified when we were building the data model. So any query that we build is very, very detailed, and we are able to ask about any aspect. If it was defined as a single fact, we will have to, in this place, ask for assets held for trading, which are derivatives at notional amount from the UK credit institutions in Europe that refer to commodity risk from over-the-counter market. Quite difficult. So having it split into different little things that make sense allows for easier query. It also allows for easier mapping to databases and checking for changes. And this is what I would like to show next. So we have two templates from FINREP. FINREP version 1 from 2009, if I'm not wrong, or earlier even, and FINREP revised 2. So tables are pretty much the same. They reflect the requirements for reporting of derivatives held for trading. But the thing is that FINREP version 1 has 51 data points in this section, and FINREP revised 2 has 45. The thing is that none of these data points is identical. This is due to the fact that we have different classification of instruments. We have addition of economic hedges to the portfolio, and we have introduction of a new breakdown, which is markets. So none of the information in these two tables, between these two tables, is identical. And now we have to communicate this change. Of course, we can create a new items for headers of columns and headers of rows, but does it communicate the change? I don't think so. So you can see that when we split it actually into different breakdowns, it's much easier to say what was the relation between the old version of requirements and the new version. So let's take a look at the old version. We have here a number of different breakdowns. So first of all, the category or instruments that we are talking about here is derivatives. Moreover, there are derivatives held for trading. So they are not derivatives held for hedging, and they are not derivatives that are designed at fair value through profit and loss. They are a specific category which is held for trading. Moreover, these different derivatives are either assets on the asset side or on the liability side, or is their notional amount, which means that we have two different breakdowns which reflect this classification. If a derivative its measurement is positive, it goes to assets. If negative, goes to liabilities. And the notional amount is the amount that is the notion of the underlying financial instruments. The next breakdown that we have here is a risk type, where we have different risks and the different instruments in which we can which detail these derivatives. So at the end, we have a number of breakdowns, and you can see that actually what was changed between the revised 2 version and version 1 is only a few breakdowns. Not all of them has changed. So in the revised 2, we also have derivatives. However, we have a new portfolio, which is held for trading but hedge accounting. We have the same base items, same amount types, same risk types. We have fewer instruments, as you can see, and we can also a new breakdown, which is market. So actually, this model communicates the change between these two different templates. Some of the breakdowns remain the same. There was one difference in the breakdown of portfolio, so financial institutions must take care of that and be able to have it in their data systems. There was a reduction in number of required instruments, so there is only one instead of a number, and there is a new breakdown. So reporting institutions must be able to classify the instruments according to the market. So the idea of the data point is that we split the information according to these different characteristics. And we use a special vocabulary terminology here. However, we're still working on making it perfect. It will probably never be perfect, but at least close to perfect. So a base item, a data point is identification of a base item and all the breakdowns that are applicable in order to make sure that every piece of information in the data model is named explicitly. So we start with the base item, and the initial definition is that base item is a significantly distinctive basic financial term, and actually it also refers to which framework we are talking about. So FINREP, which is made mostly IFRSs, the base items are assets, liabilities, income, gains. For core, we have equity exposures, and the interest rates, we have narrowly defined exchange rate and transactions businesses. In the statistics, we actually have very similar information to what is in FINREP. And these base items, we try to make them consistent so that at the end we have a common framework for FINREP, core, and the statistics, which use the same primary item if they mean the same. And the breakdown is a certain view of a base item from a certain perspective. For example, the composition according to the selected criterion, disaggregation or indication of a certain notion. For example, the CRD or IFRS scope of consolidation. And if you take a look at the different base items and the properties, you will figure out that neither of the properties you can regard as the one that is prevailing in the model. So we all know what assets are. These are the instruments, and in this case, the financial institutions, mainly the financial instruments that are owned by the entity and shall generate the economic benefit. Liabilities, on the other hand, are those instruments that were issued by our entity. And the incomes, gains, losses are the results on sales or increase in value, decrease in value of this instrument. And now we can in each of these different base items, we can have the same portfolio breakdown. For example, we have held for trading, which means that these are the instruments that are acquired or incurred principally for the purpose of selling or repurchase in the near term. So we can have assets which are held for trading, we have liabilities which are held for trading, or income, gains, losses from assets or liabilities which are held for trading. Of course, held for trading is not the only portfolio. We have available for sale, we have designated at fair value, but we have also a different classification that we can see and view the assets, liabilities, or income and losses. This is the instruments. For example, we can have the debt instruments, which are contractual or written assurance to repay a debt. But at the same time, we can have the held for trading portfolio that is applicable to different instruments, and we can have debt instruments that are applicable to different portfolios. So as you can see that neither the instrument nor the portfolio is the prevailing dimension. So we are not able to define a base items less generic than assets, liabilities, or income, gains, losses, because later we are not able to consistently apply the breakdowns. How does it look in terms of the content and format? So we start with the Microsoft Excel, simply because everyone has it, and everyone is able to review the Microsoft Excel format data model. And this data model has a number of worksheets. One which identifies the base item, the other one which identifies the members and dimensions, and there is one for each of this identification of the domain that identifies the hierarchies. There is the optional data point structure table. Anyway, I will present it to you in a moment and refer to these points on the examples of the FINREP, core, and statistics. And how does it look, the development process? First of all, you have to have the knowledge of the underlying information requirements. In case of FINREP, we have the templates, the guidelines, IFRS 739, and some other documents. Then we try to analyze the model table by table. So we start, for example, with a balance sheet and try to figure out and break it down into these different domains. And we identify and name them in the Excel and try to be consistent. So if there is something that doesn't fit in the domain, we create a new domain and try to build around the elements of this kind and later use in the modeling. And always we can go back and change something if the initial classification of an item was not correct. So how does it look for core, FINREP, and statistics, these information requirements and data model? First of all, they are totally different things. So at the beginning, we are in the last position where we start to combine something that normally doesn't go together that easily. FINREP, which is the IFRS reporting of financial institutions, core, which is capital adequacy, and there are just very few things in terms of the base items that relate to FINREP. But in fact, at the end, you will see that there is a number of breakdowns that are applicable in both scenarios, and the statistics, where the purpose is totally different, to make sure that we are able to historically compare the data and measure the amount of money in the economy. Also, the breakdown is different. The stability, of course, the BSI mirror, the statistics should be the most stable, while the IFRS is changed every year. Similarly, we have the improvements to the Basel II, Basel III, and etc. CRD3 directive. So this is also changing. And of course, the structure is different. IFRS are principle-based, and the FINREP tries to be more or less like this. Plus, they add some templates. COREP is very large tables with a lot of data exchange. And the statistics is based basically not that much data, but has to be very, very frequently exchanged. The population of reporting entities is also different. There are some that classify as reporting for the statistics, or they're only for COREP or for FINREP. The consolidation scope, which I mentioned already, for the FINREP we can use both right now for some tables. COREP is only the CRD, and the statistics has nothing to do with either. And also the valuation, so how measurement is done in FINREP, COREP, and statistics is totally different. But at the end, we are able to build some and identify some things that these frameworks have in common, and in this way we are able to actually say and build a big framework of all these different between all these different reporting requirements. So just briefly, what is FINREP? FINREP is a set of tables. Right now it's about 25, but some of them are ABCD. So in total it will be around 40. We have the core part of FINREP, which is the balance sheet and income statement, and everything else is disclosures detailing the core part. So actually you can see that most of it is related to the assets and liabilities. Some are related to income statement, and there's of course a statement of changes in equity and some more detailing tables that are not really one-to-one detailing of the balance sheet, but they are somehow related. For the core, the situation is pretty similar. We have the CA template, which is the aggregation of all the data, which allows to measure and calculate the capital requirements. But of course, in order to calculate these requirements, we need information about the credit risk, market risk, and operational risk. So this information is also provided in the detailed layer of core. And the ECB statistics, they have defined a list of codes at the ECB, which is more or less similar to our breakdowns, but it's less normalized. And in some cases, the categories that we have classified as a certain breakdown, they mix it between different breakdowns in order to make the model easier. But making the model easier makes it also more difficult to maintain, because later you're not that easily able to communicate the changes. However, it works, and we were also following their structure when we were building the taxonomy for the ECB statistics for Spain. There is this joint expert group on reconciliation, which I told you about at the beginning, and their task is to figure out the differences, similarities between these different frameworks. And there is a comprehensive document published by this group which identifies, for example, for the counterparty sector classification, what are the same or different sectors between the frameworks. Also, there are other differences that are not related to the classification of sectors, but to the meaning of financial concepts. For example, there is a reconciliation between ECB statistics and FINREP between different instruments, because in fact what is in FINREP is differently treated to what is in statistics. For example, this is one, the short positions are not included in statistics at all, while in FINREP they are included in loans, debt securities, and equity instruments on the asset side, and they are separate items in liabilities. And at the end, there is a lot of documentation that proves and shows this reconciliation. So we are able to track the changes, and if we are reporting COREP and we start to report FINREP, we're able to see what is required by FINREP simply by showing the reconciliation between these two frameworks. This is to show you how much we can reuse actually between these frameworks. So this is FINREP 1 version, and FINREP 2 actually, it only extends FINREP 1 with one breakdown, which is market. Everything else could be modeled using the same breakdowns. Of course, sometimes there will be different members in these breakdowns, but the same classifications will be used. So it should be easy to see the differences between these two models. Then the statistics reused actually 9 of the FINREP breakdowns and introduces 4 more. So actually only 4 new breakdowns were needed in order to define the statistics information if you have the FINREP classification already. And if you add COREP to that, you can see that COREP reuses 11 of the dimensions of FINREP and statistics, and actually 8 which are common to both of them. So there is a heavy reuse which allows to link these 3 different frameworks. And actually, we analyzed it also for the Solvency II taxonomy, and it turns out that the insurance sector is able to take 12 of the domains of the different breakdowns which are already applicable in the banking sector. So we can have a linkage between the insurance and the banking. And here's a set of links that you can later check yourself. I will show some of them. They are mainly on the Eurofiling info website, and they present the data models and taxonomies for the statistics, FINREP, and the COREP. So let me show you one of them. For example, the statistics first. So the statistics data model, as I told you, they are all in Excel, and they are built in this way that there is a number of worksheets. Each of the worksheets is a different breakdown. However, each breakdown is defined once just as a list of items, and in the second time as different hierarchies of these items. And as I said, because of different classifications, we can have a hierarchy of liabilities defined twice, depending on what we are trying to classify. So the number of domains in neither of these is more than 20 or 25. However, the number of dimensions is bigger. And this is because, as I said, we can have the same breakdown. For example, currencies reused by different dimensions or time intervals. In this case, interval. We have time interval, which is different periods in time, and we have at least 3 or 5 different dimensions that we can join together in order to express the information from certain tables. The BSI statistics in the data model, they have something which is called the data points worksheet. And this data point, for each cell of the information requirements, define what is the base item and what are the applicable dimensions and what are the values from the domains for these dimensions. So let's try to open one of the templates. We can use the one that we had on the slides, which was the this one, and we can try to look for a cell. Actually, this is not an Excel, so it will be hard. I need to open the Excel version in order to know the reference of a cell, but it's not difficult. Just a moment. Okay, so let's pick a cell which is actually they use code. So let's take a cell. This is table UN1, and the cell is 0008. So if I go back to my model, and I go to UN1 in the list of tables, and the cell that I want to analyze is 3 zeros and 8. I can see that this cell refers to assets, and I can check what kind of assets it is. It's actually loans. I can also check what is the counterparty, which in this case is other general government. The geographical area in this case is Spain for the location of activity, and not allocated for the residence of counterparty because it was the first column which was for total. And I can do the same for each of the dimensions applicable for this particular cell. So as you can see, if I first go and identify all the different breakdowns and later put them in this worksheet, I can make sure that for each cell I will discover all the breakdowns, and I will not forget about any property that could be important but is implicit in the table. So in this model, we can make it very, very explicit. So this is the statistics. I'm not going into details showing what are the breakdowns and what are the members. You can see it for yourself. Especially that we also want to show you the tool in the moment. So that was the statistics. For the FINREP, we also have the templates, we have the data points model, and we also have the taxonomy. And the same for CoreApp. The thing is that for the FINREP and CoreApp, we still are in the drafts. There is no final version of the templates developed by business experts. So we have the draft, and we wait for the changes that probably will come together with IFRS 9. However, there is the taxonomy and there is the data point model which you can view for yourself. So how does it look later in the taxonomy? And this is the description of the draft architecture of the Eurofiling taxonomy. There are two layers: the conceptual layer, which is the dictionary of all the items, and the presentation layer. So these layers we try to make separated, because presentation layer changes very often. You could see that there were views that changed for table 3, but actually what was the underlying information was quite stable. So one of the breakdowns was changed and the other breakdown was added. If we build it only on the presentation relationship, it will be very hard to learn the semantic changes. So the aim is to make sure that the model and the taxonomy is consistent and it's flexible in terms of how to shape the views, and it's easy to maintain and implement on both sides, on the supervisor and the file level. In order to make this analysis, as I said at the beginning, the business analysts need a data warehouse. And this data warehouse could be built according to what we identified already. So we have the loose list of concepts that we identified, packaged in different buckets, and later we build the hypercubes based on that. So this is pretty stable. And then the views that actually are presented in the user interface, they are very flexible to shape, because they can be built similarly to the BI tools work, like queries on this dimensional relational data model. The structure of the taxonomy resembles these layers. So there is a separate folder that only contains the stable part, which is the part defined for the dictionary and the dimensional relations, and there is a flexible folder that will change, that simply defines the views on the tables and certain rules that are views dependent. There is also a folder inside of the main model that defines the hypercubes. The rest of it defines the dictionary. This table summarizes what goes where. So the common dictionary, we have the I haven't said that, but what we try to do in the Eurofiling is to resemble with the taxonomy also the framework of the relations between different domains. So that there is a certain place, a certain folder when we store information that is related to CoreApp, FINREP, and statistics at the same time. And there are separate folders that are related only to FINREP, only to CoreApp, or only to statistics. So we try to keep separate what is really separate, but what goes together is defined in the same place. Therefore, we have a common dictionary and we have specific dictionary for a certain application. Then there is functional relationships when we have the hypercubes, and the presentational relationships where we have the rendering. And this is the same presentation, but in the structure of the folders and files. So we have the base concepts, so primary items defined for the common dictionary, dimensions defined for the common dictionary, and each of the domains separately. So each of the breakdowns defined for the common dictionary. We have exactly the same for the domain specific. For example, the concepts that are only applicable to EBA or to ECB, in order to make sure that there are certain copyrights on these concepts and so on. There is the common hypercubes or cross-template hypercube section, and there is the views which are defined in the separate folder. And what is interesting in this approach is that in order to have this flexibility of separating the model from the views, we have the table link base. And this table link base is a generic link base according to the XBRL specification that defines the views. So it allows to flexibly model a link base in XBRL that resembles the views of the original templates, which, as you can see, we broke down into a number of different dimensions. So the idea is that this link base breaks the view into 3 different kind of axes: Y, X, or Z, depending what we want to represent. We are able also, as a nested coordinates, to resemble the hierarchical structure of the headers of rows or headers of columns, indicate that some of them are just gathering other columns or rows. They are not actually having any value. There are generic labels and references to indicate the values that goes into headers of rows and headers of columns. And there is a specific logarithm and algorithm of inheriting the information from higher level coordinates. So at the end, this table is modeled according to the 3 different axes, where each of the breakdown takes appropriate values. There is also a new thing in the architecture of the Eurofiling taxonomy that is different to, for example, US GAAP or IFRS, is the naming convention. First of all, we don't change namespaces because every change of the namespace requires change in the mappings. And in time, it doesn't make sense to have that many namespaces and then remappings. So there is, of course, the identification of the file in the processing instruction, but the namespace shall be stable in time. And the same for the naming convention of primary items and dimensions. We simply use a specific code, which is that sometimes we try to identify some of the semantics, sometimes not. In case of primary items, we identify data type, then whether the element is instant or duration, and then there is a sequential number. But if there is any code applicable, for example, the ISO code, we try to use this as the name of the element. Now, the Excel add-in, before I show you how it works, in short, it was developed in order to facilitate creation of the taxonomies according to this model. So actually, it's able to produce this taxonomy for the primary items, dimensions, domains, and so create all the schema and link base files automatically out of the Excel in the proper format. And it's also possible to create this table link base. It was developed and works under .NET and requires Excel 2007 or higher. It was developed, it was actually a byproduct of a project. It wasn't intention of the project to develop this product. It was just something that was very helpful in order to conduct this project. So this tool right now is an open source, publicly available, and it's being tested, and actually its functionality is being extended by a number of people. And there is a different project right now in one of the European central banks to build a proper product of this kind, having a much bigger functionality. So what does it do? It has a hard-coded taxonomy architecture that it outputs, according to what I presented before. It reads information from the Excel and builds the schema and link base files. And it's also able to save this information from the loaded from what was loaded from the Excel in this tool-specific format. Again, if you install it, you'll have another tab in Excel with a number of features. I will show you how it works in a moment. This is where you can get it from, the OpenFiling website. And there is the source code if you want to play with it, executable installable version, the manual, how to install, and the user guide in form of slides. And I will present it to you based on our proof of concept that is also on the Eurofiling website. This proof of concept was built in order to show how this taxonomy and the modeling could look if we take a set of a number of templates. In this case, it's 11 templates, which come from statistics and FINREP mainly, and they all already include the change that we anticipate of the IFRS 9, so that it's easier to model the requirements of FINREP when they come later this year, including the IFRS 9. There is the data points model as well for these templates, which I will show you in a moment. There is the taxonomy generator file that you can load and actually, instead of defining it from scratch, you can play with already existing taxonomy, and it's able to output the taxonomy for the main components, so the common and domain-specific primary items, dimensions, etc. Right now, we did it manually. I mean, not manually, but outside of this functionality of this tool, the hypercubes. However, there is a plan to include the possibility to define hypercubes in the functionality of this particular tool. And the templates here contain the table link base, which I will show you later in RL, another open source tool where you can actually open these files and see the very nice view. And it also contains a number of formula link based examples for the templates and cross templates, so to check value between different tables. And again, where to find it, everything is on the internet in this location. So let me show you this proof of concept and the tool as well. So as I said, what we start with is the original template. So this is what we are given by business users. And here there is a number of tables, 11. Balance sheet, income statement, some impairment table of debt instruments, details on derivatives, breakdown of assets by counterparty residence and currency, details on certain loans, tangible and tangible assets subject to operating list, statement of changes in equity, and a few more. So these tables look very familiar to some of you. They are very simple. However, they we try, as I said, reflect core FINREP and the statistics. What is important here, which I haven't said, is that sometimes before you actually start playing with defining the rendering and even understanding the model, you have to normalize, at least to some extent, the view of the table. For example, this table over here, it contains information about assets broken down by counterparty residence and currency, which is in the headers of columns. So what we have in the headers of rows is different classes of assets, and there is some piece of the counterparty sector. But what we have here in the last line is, according to the header of a row, it's total assets. However, if you take a look at what is in the rest of the headers, you will see that this is not actually a total asset because it doesn't take into account other assets. It doesn't make sense to break down property, plant, and equipment or a different asset than financial into different currencies and different residences because it's just not applicable. So that's why this row is excluded. So what this row is actually is not the total asset, but only the total of that. That's why what we have to do is to normalize this table. So to make sure that we include the row that says that this is actually debt instruments, equity instruments, and derivatives, and the total is actually not the total, while the total in other assets is only applicable to the last row. So the normalization is needed in order to make sure that what is defined in the table makes sense. And later, when you apply the rendering, you will see that otherwise you wouldn't be able to apply this rendering. So if you try to actually approach the data points modeling right now, and you start with this table, you'll probably create a new worksheet for the data model. And in this new workbook, you will start by identifying what is the primary item here, what is the base item. In this case, it is assets. So we probably put assets in this tab for the base items. Then you will try to figure out what is the next breakdown. In this case, I have a breakdown class of assets with these different members. So we'll define a new worksheet and first create just a list of classes. And then I would need another worksheet to identify the hierarchy of it. In order not to lose this information, so I know always what are these other assets which I'm including here. So the hierarchy would look like total assets, and then underneath, and for each of the property that you figure out from the original data model. So if you do it for all these tables here, you'll actually end up with something like the particular or for this information requirement. So there are base items. Of course, you have all the technical semi-important for the business users is this column, and later application of this column in the hierarchy, and a hierarchy for these categories. Comprehensive income, different amounts type, portfolios, again with different classifications depending on the alternative point of view on the sectors, and so on and so on. So this is the data model of these. Also have some more information here on the data model, which allow me to automatically generate the taxonomy. What I need for the taxonomy, where to output this taxonomy, where should be the schema file or common schema file for the items that are common for all the information requirements from different frameworks, where to define my dimensions. So all this information is needed in order to. So if you install this Excel add-in, the thing that you have to do is go to the XBRL add-in generator add-in information from this sheet. So first you have to specify what is the worksheet that you extract this information from, because actually this tool allows you later to load the same information, change something, and regenerate the taxonomy according to these changes. So in this case, I have this is where I have my Excel workbook. My worksheet, in which I have defined all the properties of the domains, is this one. So clicking on this arrow, it takes the name of the worksheet. Then I have to identify a number of properties related to the dimension prefix, the namespace of the schema that will hold all the dimensions, the dimension schema file name, and the common dimension schema file name as well. So for those dimensions that are common between different frameworks. Then there is a number of properties that will help us later to use this tool. So identify the code for each of the domains, the name of the domain, prefix, namespace, and the location and the name of the schema file for the domain, for the framework specific and for the common items. I also identify in this worksheet where is the link to other worksheets, which will help me to load the data from those other worksheets. So in column C, I have actually the information about the other, the link to other worksheets. I also have to identify the worksheet when I have all my data types defined, because as you can see, we use very short notation for definition of the data type. However, in order to generate in the XBRL taxonomy, you have to know the local name, the prefix, the schema location of the schema defining the data type, etc. So if you have it in this right order, you only identify that this information is defined in the worksheet, which name in this case is capital letter DT. And now what I have to do, I just load the information, and as you can see, the tool goes through all the worksheets and links to them and defines a different domains. So actually, if I generate it right now, I will have a number of empty files. But I don't want empty files. I want to have files with different primary items and domain members. So in each of these different domains, I have to specify what is the information. I need to specify the necessary information to define my different items. So first of all, I start with label. So the second column actually defines labels. They then identify what type of item is it. Is it a primary item or an explicit dimension or a member? Then I need to identify what is the name of the item. So it's the XBRL schema element name, the ID, period type, so instant or duration, data type according to our list, which you can of course extend, Identification if the item is common. So whether it should be defined in the dictionary that is common for the FINREP and statistics or the EBA and ECB, or whether it should be defined only in the specific for the specific domain. So if it has an X here, it goes to the common dictionary. And the comment, if necessary, I can also specify. It should end up later as documentation name. Now I can set this configuration as a default for all the worksheets, because actually it's the same for all the different worksheets. And I can click Load Items. Now it goes through all the worksheets with the content and loads all the information. So I can actually right now go to the Edit Domain list and see all the information defined. So for each domain, I have a list of items. I'm able to export it right now as XBRL taxonomy by clicking Export XBRL and identifying the language. In this case, it's English. I identify the location. I'll put it on my desktop. And there it is. I have a taxonomy folder on my desktop, which contains the main folder according to our slides. Let's go back to them. The main folder here, it contains this table part with the common section where we have domains that are and breakdowns that are common to the entire framework, and breakdowns that are applicable to certain usage for the ECB or EBA. And inside, I have different domains, and inside of the domain, I have there the list and the labels. And for the domain specific, I also have the hierarchies. So if I go to, for example, GA, I have a number of elements defined in the schema, EMU, X2, and X3. And I have labels for these elements in different languages. I can have them as well. And I have the tree structure for the definition linkbase. And of course, I'm able at any time to open it in any of the tools. What is missing right now is two things, the hypercubes and the table linkbase. Definition of the table linkbase is very, very easy with this tool. In order to define the definition to the table linkbase, I have to open my original tables and switch the view to data points tree. The tool opens a new window pane where I'm able to define the information for my normalized tables. So let's from this table pick one. Let's pick table number 5, which is this one, asset by counterparty residence and the currency. And let's define the rendering, the table linkbase for it. I start with defining a new statement, and in the statement I can have many tables. A statement will be reflected as a new schema file. So what I need is the location of the schema file and the namespace. Actually, I prepared it already in my data point model. I have a new worksheet which I'm able to copy the information regarding the namespaces, file names, and the role URIs beginnings and the role definitions for each of the tables. So this is table 5. So in the target file names, target namespace, I copy my namespace for table 5. I want it to be output in this particular folders, and schema file should be TO5XSD, and that's enough in order to create the schema file. Then in the side of this schema file, I want to have a reference to a link base, so I click on the new table, and this table actually, the extended link will be, again, I can copy it from my data model. Name of this extended link, name is TO5. It's going to be output as ID, and the role type definition is table 5. And now what I have to do is link it to the original tables. So first what I can do, I can identify the information which is in the headers of rows and in headers of columns. So if I mark headers of rows and I click on the icon add row definition, the tool will automatically create coordinates according to the nesting and in the Excel, and it also follows and creates the labels for these coordinates in the generic link base. I have to do the same for headers of columns, so I mark headers of columns and I select add column definition. So now I have information for both. As you can see, for the headers of columns, it didn't read the information properly. I have some empty coordinates, so I simply remove them as they are not necessary. Moreover, what I have to check if there are any abstract coordinates. You can see that EMU and other than EMU are actually abstract. Another feature of this tool is if when I actually click on a cell that was used to produce the hierarchy, the tool automatically goes to the coordinate that reflects this particular cell. So this coordinate, as you can see, it's abstract. It doesn't have any value for EMU total. So what I have to do is to right-click and indicate that this coordinate is abstract. Same for other than EMU in EU. Then what I have to do is to identify the information which is behind these coordinates. So let's start with loans. In order to identify what is hidden behind the loans, I have to right-click on it and edit the coordinate values. Now I'm able to select from my different breakdowns what are the dimensions and what are the members for the dimensions. Base items, of course, this table is for assets. So assets I will assign on z-axis, the one that is applicable to the entire table. I don't need to define the base item for this coordinate. But what I do need to define is go to the categories, and actually categories of assets, and indicate that this information here is loans. This is what is hidden under this header. These loans are broken down by non-financial corporations and households. So I have to go to this coordinate, non-financial corporation, edit coordinate values, select the proper breakdown, in this case sectors, and in sectors identify non-financial corporations as the coordinate as the value for the first coordinate, and I can actually copy this information with control on households and edit the value to a proper one for this particular coordinate. Of course, if I want to be explicit, I have to say that the loans are actually total for the counterparty sector. However, if I go back to my data model, you will see that in the sectors domain, the total is indicated as the default member. Therefore, it automatically outputs into taxonomy as a default. So whenever there is a default, you don't have to specify it explicitly in this presentation. Then I have to do it for each of the values in my rows. So debt securities, I have to change the value for debt securities held. Additionally, debt securities held from the counterparty sector must be other than retail, as households are not allowed or are not able to actually issue debt securities. That's why the proper counterparty sector in this for the debt securities is other than retail. I have to do it also for equity instruments, derivatives, etc. After I do it for the headers of rows, I do the same for the headers of columns. So where I have my EMU, I select from the geographical areas the counterparty residence, which is EMU. For the other than EMU in the European Union, I can copy this property and change it to the applicable one. And of course, inside of the EMU, I have Euro. So from the currencies, I select Euro and other than Euro for the other coordinate. And of course, I can copy it to my other coordinates. So by doing so, you are able to explicitly name all the properties of all the headers of columns and headers of rows. So actually, if I didn't know this table, I would actually go one by one. So I'll probably start with the z-axis. So in order to add a z-axis, you click on these three little arrows, and then you add a coordinate. And on this coordinate, you can edit coordinate value. So I'll start with the first breakdown, which is base items. This whole table is applicable to assets. So this is what I would pick up as the first choice. Then I would go for categories. Actually, here, the information about categories is defined in the headers of rows. So I skip it on the z-axis. From the comprehensive income, there is nothing applicable for this particular table because this goes to a different tables. From the amount types, of course, I have to specify what is the amount in this table. In case of this, the table 5, this is carrying amount. But at the same time, it could be information that is notional or outstanding. And one by one, if I go through all the breakdowns, one more portfolio, which is very important here, because loans, debt, securities, equity instruments actually fall into different portfolios. So on my row axis, I would have to specify what portfolio loans is. So in this case, loans are IFRS 9 portfolios, and actually they can be measured at profit through profit or loss or at amortized cost. So this is the proper choice for this particular row. Of course, this information that I define for upper level coordinates is inherited by lower level coordinates. So in place where I define for this coordinate the counterparty residence as EMU, I don't have to define it for the Euro coordinate or other than Euro coordinate because it's inherited. However, what I can do, I can override it. So if I define a different counterparty residence here, I will override this first selection. I can also clear it out. So I can, if the information about the counterparty is inherited, I can clear it for a lower level coordinate as well. And there are of course more things that you can define here. For example, these codes that are commonly used, you can identify for each of the coordinates a cell code where you say what is the actual number, and later it will be output in the label link base as a specific type of label. Moreover, in some tables like this one where you have the references, you can also add a reference simply by saying that for my EMU, I have this kind of text to be added as a cell coordinate reference, and it is added and output later in the taxonomy. So there is a lot of other properties that can be defined. At the end, what we can do is we can actually review this model. So when we define the coordinates for the entire table, we can close this window pane and open the one review coordinate values. And then you click on any of the cells, you can see that the properties displayed change according to what is the information in the headers of rows and headers of columns. So you can at the end review the model if it's correctly defined. And at the end, you're also able to export it to XBRL, and the export I'll do right now will include the part of the rendering link base that just was created. So I have here, apart from the main, I have domain specific information where I have table 5, and I have this rendering link base, the table link base, and the coordinates, labels for the coordinates. So I can later, of course, open it in some XBRL tool and see how it looks. So I will show you what you can load from the Eurofiling website to play a bit with it. So let me close these two Excels. And on the Eurofiling website, you will be able to find a file which is called which is called Taxonomy Generator Sample, and then the information for which tables it was generated. So this is for table 3, 5, and 7. So if I open it, the tool will prompt me, or if it was in a different folder, it will prompt me for the DPM. And if I go to the domains tree, you can see that I have already 3 tables defined, including all the required properties. And all these properties are developed from the data model, and then they are input in this rendering link base. So if I open, for example, this taxonomy or an instance document prepared in the Taxonomy FINREP tool, the open source tool, this is solvency. Let me try to find the example for the Eurofiling. Here it is. So I have the instance document, which I can open, and this is the taxonomy that we generated out of this Excel tool. And it loads all the information right now, and it shows me the table view and also shows me some other properties. What I need to change is I need to change the language of the coordinates from the label link base to English in order to see the titles properly. And I also want to turn on the dimensional validity. So it will automatically gray out these cells that are not valid according to the definition link base. So this is the table 1A assets, and it's exactly the same table that I have in my templates over here. You can see that it also includes the title, it includes the references, and it's exactly the same as in my original view. I can change this table view to table 3. Table 3 is, according to my model, it's this table. You can see that this table has something gray out. And if it's grayed out, it means that it's not defined in the definition link base. Hence, it's also grayed out in the display of this tool. If I go to table 5, you will see the table that we were defining this view for a moment ago. So it was the table that we started from. And again, what is grayed out is grayed out. And one more table that we have here is table 7, which is, I believe, the table of tangible assets and intangible assets subject to operating list, and it's exactly that. So the tool is easy to use. It's quite simple. What you need to have is a proper input, which is this data point model built according to this way. You can have different ordering of columns sometimes, especially in these places where you can specify in which column a particular property is taken from. But there are some rules that are hard-coded. For example, the structure of the hierarchical structure must be defined in exactly this way. Everything what has to be hard-coded is written in the documentation of the tool. If you go to the user guide PDF on the OpenFinding website, it guides you step by step exactly with what I did right now. So it allows you to read this data model and apply it to the original rendering tables. To sum up this discussion, maybe I'll go back to agenda to recap. So there is the problem with this data model, but there is a solution to overcome all the, well, maybe not all the problems, but most of the problems that we have. And one of the solutions is, as we said, to try to define a different very little building blocks and try to build from these building blocks according to the divide and conquer approach. Even if we have very difficult information requirements for very, very different frameworks such as FINREP, COEP, and statistics, if you apply this model consistently, you can show the relations between the different models. And the question is whether the taxonomy should reflect exactly what is the data model, or whether it should be simplified for some purpose in order to make this syntax less difficult. But this is something that still needs to be discussed. If the taxonomy is exactly the same as the data model, there is this benefit of taxonomy carrying all these semantics that I showed you that allows to clearly identify the changes between the templates from one version and the other version by simply looking at those breakdowns that have changed. The same goes with the relations between core, FINREP, and statistics. If you follow this data point model in the taxonomy architecture, you are able to see the reconciliation between these different frameworks. The tool, the Excel add-on, is used to facilitate the process of this taxonomy development. It will be improved. We already have some volunteers that work on it to add more functionalities, including the hypercube generations. There will be a new version of this tool written from scratch, and in a way that it will contain all the previously defined requirements. There is a proof of concept available on the Eurofiling website, and the plan is to approach this proof of concept from two different perspectives. So looking at the less moderate taxonomy architecture and the taxonomy architecture less dimensional, and taxonomy architecture that is one-to-one representation of the data model, in fact, in order to check what are the consequences of each of these approaches. And most likely by the beginning of September, we will have some comparison of these two approaches, and we will see what is the difference, pros and cons of each of them. So if there are any questions, please address them to the addresses on the OpenFiling and Eurofiling websites. If you would like to participate in this project, please, there are files that you can download and play with. And if you need any other help, please address it on the emails on this website. Thank you very much, and we wish you a pleasant evening, or whatever time zone you are, afternoon, whatever. Thank you very much, and